Galvashield XP is a Type 1A alkali-activated anode with a cast zinc core, precast in a highly alkaline mortar matrix with a pH of 14 that is corrosive to zinc but not to steel. For reinforced concrete applications, the anode zinc cores corrode to protect the reinforcing steel embedded in the structure. Zinc has a high corrosion rate and a relatively low rate of expansion compared to other metals, including steel. This makes zinc anodes suitable for applications where the anode is embedded in the concrete structure. Type 1H halide-activated anodes require the zinc to be in direct contact with corrosive salts to cause the zinc to corrode, such as calcium chloride and lithium bromide. The principal risk of halide-activated anodes is that the halide ion is corrosive to both zinc and the reinforcing steel. In this demonstration, we placed 4 pieces of new rebar in distilled water with pulverized mortar from 4 different anodes to illustrate the corrosive effects and deficiencies of Type 1H halide-activated anodes. After just 24 hours, the corrosive halide activators in the Type 1H mortar begins to corrode the rebar. The rebar in the Type 1A alkali-activated anode mortar shows no sign of corrosion. After 14 days, the rebar exposed to the alkali-activated anode mortar still shows no visible sign of corrosion. Galvashield XP anodes feature one-and-done single-wire connections. A single stainless steel tie wire provides direct steel-to-steel contact and up to 2 times faster installation versus double-wire connections. The strength and flexibility of the stainless steel connection allows for a simple, secure, and redundant long-term connection. Type 1H halide-activated anodes require galvanized steel to keep the halide salts from corroding the steel tie wires. The inclusion of galvanized steel means the connection relies on the zinc steel coating to remain intact over time. If the galvanized coating on the steel wires corroded, resistance will build up in the connections, and there is a high risk the anode will become disconnected and non-functional. The Galvashield XP stainless steel wire is cast within the zinc core for high efficiency and utilization. This seamless construction ensures the zinc will remain electrically connected to the steel tie wire with virtually no risk of crevice corrosion. However, this particular anode features 2 zinc plates with 2 bolted connections for a total of 10 individual core components. The bolts and fasteners secure the plates and the tie wires within the Type 1H mortar matrix. This model features 3 zinc mesh plates, soldered together at one end, wrapped in galvanized steel tie wires, and encased in a Type 1H lithium bromide mortar matrix. Both models are at risk of crevice corrosion and a loss of electrical connection between the zinc and the steel tie wire. This would lead to the breakdown of the corrosion mitigation system. Crevice corrosion is a localized form of corrosion that tends to occur in crevices such as those formed under gaskets, washers, insulation material, fastener heads, surface deposits, disbonded coating, threads, lap joints, and clamps.